All right, on example 9, says again, solve the equation on the interval from 0 to 2 pi. We've got sine of theta minus sine of the triple angle 3 theta equals 0. Okay, this is one of those where we're going to use that sum to product formula. Okay, this was back in our section 6.4 where we did those sum to product and product to sum formulas. From table 6.7, formula number 8, okay, 6.7, table 6.7, formula number 8 says if you have the sine of x minus the sine of y, which is really the format of our problem here, that will simplify to be 2 times the cosine of x plus y over 2 multiplied by the sine of x minus y over 2. Okay? So what we're saying here is that left-hand side of the equation can be rewritten as 2 times the cosine of theta plus 3 theta over 2 times the sine of theta minus 3 theta over 2. Bring down the equals 0. Okay? All we did is on the left-hand side, we applied our formula that allows us to turn terms into a product. And so what we've got going on is a factor times a factor times a factor equals 0. Okay? So, let's just go for it from here. If I set each of these factors equal to 0, okay, here's a factor, here's a factor, and here's a factor. If you want to write them like that, I'll have equations 2 equals 0. Okay, I'll deal with that in a second. And then the cosine of, let's go ahead and say theta plus 3 theta is 4 theta over 2. Don't forget to set that factor equal to 0. And then we'll set the third factor. Sine of theta minus 3 theta is negative 2 theta over 2. Set it equal to 0, not theta, goodness gracious. Set it equal to 0 as well. Okay? So set each of those factors equal to 0, and then we'll concentrate on solving those equations. Now for this first one, when we set 2 equal to 0, that doesn't have a solution, right? 2 is not equal to 0. We're not going to have an answer from that. Okay, this next one says cosine of, that would reduce to 2 theta equals 0. And again, this is just going to be solving a multiple angle equation at this point. We're going to get the cosine off of there by taking inverse cosine of both sides. So we will have 2 theta equals the inverse cosine of 0. And so what we're going to do now is we're going to generate a list of angles that have a cosine value of 0. Okay? Now, the thing is, let's go ahead. I do know that we are just going to have to give answers, final answers, between 0 and 2 pi. But let's go ahead and give all the answers. Okay? That would be, let's see, cosine is 0. Cosine of an angle is 0 for angles of pi over 2 and 3 pi over 2 and so forth. Okay? So what I'm saying is let's go ahead and do pi over 2 plus just n pi. That'll get us down, if n is 1, that'll get us down to 3 pi over 2 and so forth. Okay? All right. Now what we're going to do is solve for theta. Solve for our angle theta by dividing everything through by 2. We can either divide by 2 or multiply by a half. whatever we want to do there. So our angles for theta are found by using this formula. Pi over 4 plus n pi over 2. Okay? Now, we're going to, remember, go between 0 and 2 pi. Okay? And so, this is where I say I'm going to let n be equal to 0. If n is equal to 0, then theta is equal to pi over 4 plus 0 pi over 2 is just 0. So our first answer is pi over 4. Okay? Now, if n is equal to 1, we have theta is equal to pi over 4 plus 1 pi over 2. Pi over 4 plus 2 pi over 4 is equivalent to pi over 2, okay? Will give us 3 pi over 4. There's another answer. That is in between 0 and 2 pi. Keep going. If n is equal to 2, we'll have theta is equal to pi over 4 plus, if n is equal to 2, we'll have 2 pi over 2, which is just pi. With a denominator of 4, this can be written as 4 pi over 4 is the same thing as just pi. So we'll get a theta of 5 pi over 4. There's another answer, and that's not greater than 2 pi. We're going to keep on going. Okay, when n is equal to 3, our formula above here, like this, our formula above, when n is equal to 3, gives us pi over 4 plus 3 pi over 2. Okay? And then again, we've got to get a common denominator, so build this fraction up. We'll have pi over 4 plus 6 pi over 4 will give us 7 pi over 4. Keep going. Now, here, if n is equal to 4, theta is going to be pi over 4 plus 4 pi over 2. And this is actually just 2 pi. So pi over 4 plus 2 pi is going to be bigger than 2 pi. We stop. Okay? So there we got 4 answers, and that's just 4 answers so far, right? Keep those in mind. Way back up here, we've got to solve this other equation. So if we reduce the 2's, this is equivalent to the sine of a negative theta. True? Now, apply your negative angle identity. The sine of a negative theta is negative sine theta. And then, if you want to isolate the sine, divide both sides by this negative 1. So actually, if we just solve the equation, sine theta equals 0 divided by negative 1 is just 0, we'll be good to go. Again, inverse sine both sides, so we'll just have theta equals, okay, all the angles that have a sine value of 0. All the angles that have a sine value of 0. So let's see, theta will be equal to sine of 0 at 0, at pi, at 2 pi, and so forth. But again, 2 pi, we don't include 2 pi in our directions way up here. Don't include 2 pi, but we can give 0 and pi. All right, so if we want to formulate all of our answers in order, we've got 6 of those. Going in order from 0 to 2 pi, here's our solution set. 0 is the smallest. Next is this angle in quadrant 1 of pi over 4. Next is this angle in quadrant 2 of 3 pi over 4. Next is pi, 4 pi over 4, right? Okay, or just pi. Next, we're going to have 5 pi over 4. And then the largest is 7 pi over 4. If we're going to write those all in order, there's our final answer. Okay?